Hello friends, welcome to a gorgeous day here on the beach. Previously we've talked about matter, how matter is anything that has mass and takes up space. Well, in this chapter we're going to talk a little bit more about matter, some of the properties that we see in matter, some of the way that it undergoes changes. There's a lot to cover. I hope you'll stick around. Here we go. Now you might also recall we talked about matter that has a pure, unchanging composition. We call those substances. A perfect example is water, H2O. As long as there's nothing else in it, water has a pure and unchanging composition. Table salt, happen to have some right here. Table salt, as long as there's nothing else in it, it has a pure and unchanging composition. Often we can put those substances together. They don't have to stay separate, obviously, do they? Let's take, for example, carbon dioxide that we find in the atmosphere. When that carbon dioxide enters the water vapor, it makes that water vapor slightly acidic. So when that slightly acidic rain comes down, it begins to dissolve minerals that we find in the rocks, the soil around us. And when that stuff runs off into the oceans, it creates a saltiness, a salination of the water. But water, carbon dioxide, table salt, these are all examples of pure substances. We put them all together and we get mixtures, which we'll talk about in section 3. And we can also see that we have what are called states of matter: solid, liquid, gas. Here at the beach, we can plainly see solids around us, the sand that's on the beach. We can definitely see liquid behind us, and there's nothing like it, gas around us in the air that we breathe. Let's talk about each one for a second. Solids are forms of matter that have a definite shape and definite volume. Sand, wood, iron, paper, these are all examples of solids. Because the particles of matter are closely packed in a solid, that makes it extremely hard to compress. Solids largely are incompressible. Now, a solid isn't necessarily defined by its rigidity or hardness. For example, concrete and wax are both solids, aren't they? One is a lot more rigid than the other. Liquids are a form of matter in which you have flow. There's constant volume here, but the matter takes on the shape of its container. Here's a certain shape. Here's a different shape, isn't it? It takes on the shape of its container. The particles in the liquid are also very closely packed. Because of that, liquids are largely incompressible. It's hard to squeeze them together any more than they already are. Now, the particles in this liquid are not rigidly held together. They are able to move and glide past one another. And that's the reason for their ability to flow. So we said that solids have closely packed particles and liquids have closely packed particles, which make them both very hard to compress. They are largely incompressible. And whereas solids have particles that are so closely packed, it does not allow for any flow, liquids, on the other hand, have a little bit of distance that allows for flow between particles and allows that liquid to take on the shape of its container. Now, gases, the final state of matter that we're going to talk about, have an indefinite shape and indefinite volume. They have very great distances between their particles in contrast to solids and liquids. Whatever container they're in, they expand to fill that container completely. Because of the great distances between gases, there's a lot of ability to compress a gas, as we see in a scuba tank or in a cylinder of helium that's used to inflate balloons. Now, you might have also heard the term vapor before. The terms gas and vapor are not exactly interchangeable. The difference is a vapor is the gaseous form of a substance that's normally a liquid or solid at room temperature. Let me say that again. A vapor is the gaseous form of a substance that's normally a liquid or solid at room temperature. So we have a mixture of gases in the air that we breathe. Nitrogen is the greatest of those. 78 to 79% of the air that we breathe is nitrogen, and nitrogen is already a gas at normal temperature. About 20% of our air is oxygen. Oxygen, of course, is a gas at room temperature as well. It is in the air that we breathe. We use that oxygen to perform metabolic processes in our body. So we have about 79% nitrogen, about 20% oxygen, and the remaining 1% are what we call trace gases. We have things like a little bit of carbon dioxide. We also have a little bit of water vapor, the gaseous form of water, which obviously is normally a liquid at room temperature. Then we also have argon gas. In fact, of that 1% remaining trace gases, argon is about 9/10 of that. I guess you could say that argon is greater, argon is stronger, argon is higher than any other trace gas. I apologize. Before we end our discussion of this section, we need to talk about physical and chemical properties. A physical property is a characteristic of a substance that can be observed without changing the composition of that substance in any way. Things like density, hardness, smell, color, boiling point, melting point. These are all examples of physical properties. These are things that scientists observe about certain substances. Now, within that world of physical properties, we have two types. We have intensive properties and extensive properties. Extensive properties are entirely dependent on how much of that substance you have. Things like length, mass, volume. These are all examples of extensive properties, where the difference is in how much of that substance you have. On the other hand, intensive properties remain consistent no matter how much of that substance you have. For example, the density of pure water is about 1 gram per milliliter. Regardless if I have a glass full of pure water or a swimming pool full of pure water, that water is always going to have the same density throughout. Color is another example of an intensive property. Regardless of how much you have, that color remains the same. Boiling point, melting point are also examples of intensive properties. Whether I have 1 cube of ice or a bag full of ice, every bit of that ice has the same melting point. So again, extensive properties take into consideration how much of a substance you have. Things like length, mass, or volume. While intensive properties are the same regardless of how much of that substance you have. Now, some properties of substances aren't really observed until they come in contact with another chemical, another substance. These are called chemical properties. So the ability of a substance to combine with or to change into another substance is called a chemical property. For example, when iron is exposed to the open air, the oxygen in that air reacts with the iron and we have iron oxide, otherwise known as rust. That's an example of a chemical property. We could say that iron, when it comes in contact with oxygen, reacts to form iron oxide, or rust. Copper is normally a reddish-brown color, but when you allow it to be exposed to the moisture in the air, it forms a greenish substance that we call copper carbonate. In fact, this is the reason why the Statue of Liberty is green. The Statue of Liberty has a copper exterior, and when we first received her, she was that brown coloration you see with copper. But over the years, the moisture in the air has reacted with that copper to give her that beautiful green patina we see now. So we can understand a great deal about a substance when we observe the physical and chemical characteristics of it. That's all the time we have for today. We started by talking about substances once again, how a substance is matter that has a pure, unchanging composition, things like water or table salt. And then we talked about solids, liquids, and gases, states of matter, how solids have a definite shape and a definite volume, how liquids have a definite volume, take on the shape of their container, and how gases have an indefinite shape and an indefinite volume. They will expand to fill their container entirely. We said that while solids have a rigid arrangement of their particles, liquids and gases do not. And because of that, it allows for something we call fluidity. Remember also, we described a vapor as being the gaseous form of a substance that's normally a solid or liquid at room temperature. Steam, for example, is the gaseous form of water. We would call that water vapor. Then we talked about properties of matter. We talked about the two main types, physical properties and chemical properties. Remember that physical properties are divided into intensive properties and extensive properties. Extensive properties have everything to do with how much there is, and intensive properties are consistent regardless of how much of that substance there is. And finally, we discussed chemical properties, the ability of a substance to combine with or to change into one or more substances entirely. So I hope that this has been beneficial to you and informative. I hope you've enjoyed the sunshine a little bit. I know I have. I might just stay here for a while. Lord willing, I'll see you soon. Until then, God bless.